So in this video, we're going to take some quadratic expressions and complete the square to put them in vertex form. So let's say we have a quadratic expression y, or function rather, y equals x squared plus 8x minus 16. So a few things we know about this function already. Its leading coefficient, a, is equal to 1, which means it's sort of nice in some ways. It hasn't been stretched or scaled. And we know the y-intercept is negative 16. But besides that, we really don't know a whole lot immediately. We want to know things like, well, what's the vertex? What are the x-intercepts? We already know the y-intercept is 0, negative 16. But there's some other stuff we would want to know. So to put this in vertex, what we can do is complete the square. And remember that what our goal is to get y equals a times x minus h squared plus k, because this tells us that the quadratic function x squared has been moved to the right h up k, and it's been scaled by a factor of a. So that gives us a lot of information if we can put it in this form. And what we need to get to this goal, we need an x minus h squared. And when you multiply this out, you get x squared minus 2xh plus h squared. And so we'll notice something here, that this value right here is, well, it's negative 2h divided by 2 all squared, right, which is h squared. So it looks a little bit strange in this form, but remember that to get what we call a perfect square trinomial, we're going to take our b term, divide by 2, and square it, and add it to both sides. So when we're completing the square, we're really adding that value on there to make sure that we can get a perfect square trinomial that factors to a binomial squared. So the steps here, we're going to move the 16 over just to get it out of the way. And now we're going to complete the square on this little binomial. So we're like, what do we need to add over here in order to make sure that we have a perfect square trinomial? And we better add it to both sides. Well, as it turns out, perfect square trinomial, this number needs to be 8 divided by 2 squared. That's 4 squared, which is 16. So we're going to add 16 to both sides. So now we should have y plus 32 is equal to x squared plus 8x plus 16. Now hopefully this should factor to a binomial squared. And it does, right? Because two numbers that multiply to 16 and add to 8 are 4 and 4. So this should be y plus 32 equals x plus 4 times x plus 4. And that's y plus 32 is equal to x plus 4 squared. And now if we want to solve for y, we could say y equals x plus 4 square minus 32. So adding 4 to x is going to move the function to the left 4. Subtracting 32 outside will move it down. So your vertex is negative 4, negative 32. Since this function opens up, we know that that's a minimum. So we've got a lot of information now, but basically 1, 2, 3, 4, and let's call this negative 32. Let's call this negative 16. We know our y-intercept was negative 16. Our vertex is down here at negative 432. Using symmetry, we should get another point over here. And so we get a lot of information about our function, namely that it looks like that. Okay, so this completing the square allows us to find the vertex, which tells us things about our function. Now what happens if instead of having a coefficient of 1, we have a coefficient that's equal to something else? So for instance, how about y equals 3x squared plus 12x minus 7? And maybe we should make this negative just to be a little bit more interesting. So now we know a few things. We know the y-intercept of this function is 0, negative 7. We know that it opens down because since a is less than 0, right, our coefficient is less than 0. And we know it is scaled it's vertically scaled by 3. In other words, it should be quite a bit steeper because we've multiplied the whole thing by 3. And by it, I mean x squared, the original parent function. So in this case, we're going to follow the same process and say y plus 7 is equal to negative 3x squared plus 12x. But now we can't complete the square until this negative 3 has been dealt with, so I'll divide everything by negative 3 and say that y plus 7 over negative 3 is equal to x squared minus 4x. So I divided this by negative 3, divided this by negative 3, divided this by negative 3, and I get x squared minus 4x. Now I need to complete the square because I want a perfect square trinomial so that I can get this x minus h squared part of my vertex form. Remember, this is a binomial squared, bi meaning 2. There are 2 things here squared, whereas a trinomial is tri 3 terms. So what do I need to add here? Well, it's b divided by 2 squared. That's negative 2 divided by 2, which is negative 2. When I square that, I get plus 4, and I might make sure to add it over here as well, plus 4. Now I can factor this. I've got y plus 7 over negative 3 plus 4. I'll just leave it in this messy form, is equal to x minus 2 times x minus 2, because negative 2 times negative 2 is 4, and negative 2 plus negative 2 is negative 4. And now I can get y plus 7 over negative 3 plus 4 equals x minus 2 all squared, because that's what that is, of course. We're abbreviating multiplication with an exponent. Now I need to solve for y, so I can just undo what's been done to it. So what has been done to y? I added 7 to it. I divided by negative 3. I added 4, so let me undo that in the reverse order by subtracting 4, multiplying by negative 3, and then subtracting 7. So y plus 7 over negative 3 equals x minus 2 squared minus 4. Multiply everything by negative 3. Careful. Got to multiply that by negative 3 as well and get y plus 7 equals negative 3 times x minus 2 squared plus 12. And then subtract 7. Y equals negative 3 times x minus 2 squared plus 5. Now I know my vertex is 2, 5. Move to the left and up. And so if I wanted to think about a sketch of this function, 2, 1, 2, 3, 4, 5 is right there. I know my y-intercept is at negative 7. 1, 2, 3, 4, 5, 6, 7. It's down here. I get another point on the other side using symmetry and get a graph that looks like that. So putting this in vertex form can give me a lot of information about what my function looks like. So to sort of summarize the steps for completing the square, we could say, well, what's the reasoning for completing the square? Complete the square. Why? To put it in vertex form. What does complete the square mean? It means when you have x squared plus bx, it's to add something to get a perfect square trinomial, which is a binomial squared. Just like 25 is a perfect square because it's equal to 5 squared. So we remember that for x squared plus bx, you add b over 2 squared, and this factors to x plus b over 2 squared. Perfect square trinomial factors to that. And following these steps, you can put it in vertex form, find the vertex, which gives you the axis of symmetry, the min or the max. And in vertex form, you can also find the x-intercepts without too much difficulty. Okay.